Hello all, I am Dr. Rizvi and this is lecture 3 on simple stress and strain. In this lecture, we will discuss about Hooke's law and Poisson's ratio. So starting with Hooke's law, what is Hooke's law? Basically Hooke's law states that within the elastic limit, the stress is directly proportional to strain. Sigma is directly proportional to strain. This is what Hooke's law states. And this is under the condition that it is within the elastic limit. That means when the load is under the elastic limit, as soon as the loading crosses the elastic limit and reaches the plastic limit, then this law is not obeyed by the material. And mathematically it is represented as sigma is directly proportional to epsilon. And to remove this proportionality sign, we will place a proportionality constant and then sigma will be equals to E into epsilon, where E is the proportionality constant and it is modulus of elasticity, or it is also known as Young's modulus. This is the proportionality constant. There are three types of Hooke's constant that are based on the particular stress and strain that are related to it. The first one is Young's modulus that we have denoted here. Young's modulus or modulus of elasticity, it is denoted by E, capital E, and it is the ratio of normal stress to the normal strain under elastic limit. So E equals to sigma upon epsilon. It is the ratio of normal stress to normal strain. This is Young's modulus. And since epsilon do not have any unit, so the unit of modulus is Newton per mm square or kilonewton per meter square as per the condition that is given in the numerical. The second type of modulus is modulus of rigidity. It is denoted by capital G. This occurs in the case when the body is subjected to shear force, and it is the ratio of shear stress and shear strain within the elastic limit. So G equals to tau upon phi. Tau is shear stress and phi is shear strain, and same is the unit here, Newton per mm square or Newton per meter square or kilonewton per meter square. The third modulus is bulk modulus. It is denoted by capital K. In the last lecture, we have studied about the volumetric strain. In that case, when we consider the ratio of the direct stress with respect to the volumetric strain, then it is known as bulk modulus. K is equals to ratio of direct stress sigma upon volumetric strain epsilon V under the elastic limit, and it also have the same unit, Newton per meter square, Newton per mm square, kilonewton per meter square as per the condition given in the numerical. Now let us discuss the Poisson's ratio. Poisson's ratio. If a body is subjected to external load like this, generally in tension it its length increases. So we can say that the length is increasing, but we can say its thickness is decreasing. Initially the thickness was t and now it is a small t. So there will be a change in the dimension, in the secondary dimension or in the lateral dimension or in the transverse direction, and its nature will be opposite to the nature of the primary strain. When the load is acted upon the body, the longitudinal dimension increases under tension, but its impact on the lateral dimension is reverse, and it will decrease the size in the lateral dimension. For example, here you can see that the tensile load is acting and the length is increasing, but corresponding to it, the cross-sectional area of the body is decreasing. In this case, the linear or primary strain will be tensile, but the secondary or the lateral or the transverse strain is compressive in nature, as the thickness is getting reduced. So the Poisson's ratio is basically the ratio of, it is denoted by mu, it is the ratio of lateral strain upon linear or primary strain. It is the ratio of the lateral strain that is acting on the lateral plane or the cross section to the primary strain, in the direction where the force is acting, and it is denoted by Greek letter mu, and it is also being denoted by 1 upon m, where m is constant and its value lie between 3 and 4. M is greater than 3 and less than 4. This is the range for M for different materials. We can say that for example, aluminium, the Poisson's ratio for aluminium is mu equals to 0.330, and for steel mu is 0.288. For copper it is 0.355 mu for copper, mu for steel, and mu for aluminum. These are the various examples of Poisson's ratio depending upon the material. It is denoted by mu, or it is also denoted by 1 upon m. Thank you.